Hello, good morning, good afternoon, good evening to you out there from wherever you're joining us across the globe. It's a wonderful day. It's a beautiful day. We thank God who has made it possible and given us the gift of life and good health. We thank God who has made it possible for us to be alive today. This is the last day of the year 2023. This is 31st day of December. So after today, we are going to cross over into 2024. We give God glory who has enabled us to be alive to see today. So in this lesson, this is our series on density. I'm your host. My name is Samuel Anekan. I've been the one taking the density lecture so far. So in this lesson, we'll be solving some calculations that has to do with the principle of flotation. In our last two lessons, we looked at the principle of flotations. In our last lessons, I explained why ships float even though they are made up of steel or iron, which has a density that is larger than that of water, far larger than about like almost approximately 8 times larger than that of water. They still float. I explained that. So now we are going to solve some questions that has to do with flotation, floating objects. So our first question here, which we're looking at, is what a block of iron of mass 200 grams. So let's say this is our iron. Of 200 grams. This is the iron. The mass of iron is 200 grams. It floats in mercury. Floats in mercury. One thing we know about mercury: mercury is a liquid that has a very high density. Density is higher than that of iron. So iron is then going to float in mercury. So what volume of the block is immersed in mercury? What volume of the block is immersed in mercury? For it to float, that means a certain portion of its volume is going to be above the mercury, while a certain portion will be beneath the mercury. So what volume of the block is immersed in mercury? From principle of flotation states that a body displaces its own weight of the fluid in which it floats. A body does what? Displays its own weight of the fluid in which it floats. So before a body can float, it has to displace a volume of fluid that is equal to its own weight, invariably. So this, let's assume that this is the weight of iron. This is the weight of iron. So weight normally is, the formula for weight is W is equals to mg. So if a body must displace its own weight of the fluid in which it floats, that means the body must also displace its own mass of that fluid in which it is floating. For it to be possible for that body to float, it must displace its own mass, because weight is equals to mass times g. This is a constant. So for it to displace its own weight, it must also displace its own mass. So now that means for this block of iron to float, it must displace a mass of iron equals to a mass of mercury equals to 200 grams. So mass of mercury displaced. Okay, let me do it here. Mass of mercury displaced is equals to 200 gram. That is the mass of mercury that is displaced. So mass of mercury displaced is 200 grams. the mass of iron was 200 grams. The weight of iron, we can calculate the weight using the concept that weight is equals to mg. Okay, so if weight is equal to mg, if the weight of mercury displaced is equal to the weight of iron that was submerged, for this iron to float, that means the mass of mercury displaced is equal to the mass of iron. So mass of mercury displaced is equal to 200 grams. Now the volume of mercury displaced is going to be equal to the volume of iron that is submerged, that is immersed in the water. Take for instance right now, if this is mercury liquid, now you now have a block of mercury, a block of iron, and the mercury is immersed. When the mercury is immersed, it's going to displace a volume of water equal to the portion that is immersed. The volume of mercury that is going to displace will be equal to the volume of this thing. Okay, let's take it. Let me explain it further again. This is mercury now in this container. At this point, you now bring in iron. You now bring in a block of iron. Insert a block of iron. The mercury level is going to rise. Mercury will be displaced, and the volume of mercury displaced will be equal to the volume of the iron that is immersed. This part that is immersed is going to displace that same volume of mercury. As the iron is entering into this container, the volume of mercury is going to rise. So the volume, this part is going to take that portion of mercury, the volume of mercury that was being occupied here will be taken over by the iron. So the mass of mercury displaced, from the mass of mercury that is displaced, we can actually calculate the volume. We can actually calculate the volume of mercury that was displaced. So from density is equals to mass over volume. Volume is equals to mass. Volume is equals to mass over density. So we can calculate the volume of mercury displaced. Volume of mercury displaced is equals to the mass of mercury is displaced is 200 grams. Density of mercury was giving us 13.6 gram per cubic centimeter. That is 13.6 gram per cubic centimeter. So using our calculator, we divide 200 by 13.6. Let me do that. (200) divided by 13.6. That gives me 14.7. So that gives me 14.7 cubic centimeter. So the volume of mercury displaced is equals to 14.7 cubic centimeter. This is equal to the volume of iron block that is immersed. The part of the iron, the volume of the iron that is immersed is equal to the volume of mercury that is displaced. So this is volume of iron immersed is equals to 14.7 cubic centimeter. 14.7 cubic centimeter. That is what it is equals to. Okay. So now the second part of the question is, we've solved the first part, which was what volume of the block is immersed in mercury. For the second part, says that what is the density of the block assuming the volume of the block in one, as in question, the first part of the question we just calculated, is half the volume of the iron block. What is the density of the block? So we know that density is mass over volume. The mass of the block we know, that's 200 grams. The volume of the block we don't know, but they told us that assuming the volume of the block in one we calculated is half the volume of the iron block. So assuming this 14.7 is half of that, this is half of the volume of the block. So if 14.7 equals to half the volume of the block, then the full volume will be times 2 of this. Times 2 of this gives us 2 times 7, 14, 2 times 4, 8, plus the 1 here, 9, 2 times 1, 2. So double the volume we calculate in 1 is 29.4. So from that we can calculate the density of the block as the mass is, what's the mass? The mass of the block is 200 grams. The volume is 29.4 cubic centimeter. So that is it. That is it. 200 grams divided by 29.4 cubic centimeter. 200 grams divided by 29.4 cubic centimeters. So that is, let me divide that. Let me use my calculator to divide that. So 200 divided by 29.4, that gives me 6.8. 6.8 grams per cubic centimeter. Approximately 6.8 grams per cubic centimeter. So that is the density of the block, the density of the iron block. So it's as easy as that. So I'm going to use another approach. A second method to solve it right now. So I hope you digest that, and I hope you are with your pen and your paper. Make sure you are using your pen and paper to take down notes. So I'm going to now use method 2 to solve it. Now, the principle of flotation, another version says that a body will float in a fluid when the upthrust of the liquid is equal to the weight of that object. So this iron is going to float when the upthrust of mercury on the iron is equal to the weight of this iron. So what is the weight of this iron? Let's calculate the weight. The weight is equal to mg. So the weight was 200 grams. We convert this to kilogram. That is divided by 1000. Then multiply by 10. We assume that G is equal to 10. G was given as 10 actually. So it's not that we are even assuming anything. So at the end of the day, 3 zeros here cancel 1, 2, 3 zeros. So the weight is 2 Newton. The weight of the iron block is 2 Newton. So from principle of flotation, which states that a body floats when the weight of the object is equal to the upthrust of the liquid. The upthrust of the liquid is what? 2 Newton as well. The upthrust of the mercury acts on the block is 2 Newton. So the weight of mercury displaced is equal to 2 Newton. The weight of mercury displaced is what? 2 Newton. From Archimedes' principle, the weight of the fluid displaced is equal to upthrust. Archimedes' principle states that when a body is partially or completely immersed in the fluid, it experiences an upthrust which is equal to the weight of fluid displaced. So the weight of mercury displaced, weight of mercury displaced is equal to the up thrust equal to 2 Newton. Okay, so having gotten the weight of mercury displaced, the liquid displaced, now we can actually calculate the volume of displaced liquid. Since we know the weight of liquid displaced, weight of mercury displaced, we can also calculate the volume of displaced liquid. So first and foremost, let's calculate the mass of mercury displaced. Weight is equals to what? Mass times acceleration due to gravity. Okay, so for us to get, we are looking for the volume of mercury, which is the liquid that was displaced by the ion. The volume of mercury displaced by the ion from density is equals to mass over volume. So volume is equals to mass over density. And now the mass of mercury displaced, we don't know actually. We don't know the mass, but we can actually calculate it from this formula. From this formula, we can calculate it that mass is equals to weight over g. The weight of mercury displaced was what? 2 Newton. Okay, we can introduce this formula into this one instead of calculating separately. So we replace mass with weight over g. Density is below. So the weight there is what? To calculate the volume of mercury displaced, the weight there is 2 Newton. The weight of mercury displaced is 2 Newton divided by g, which is 10 meters per second square. This one gives us the mass of mercury displaced. So dividing by density, density of mercury is 13.6 gram per cubic centimeter. We have to convert to kilogram per cubic meter so that our units will consist 10. So we have to multiply by 1000. So we have 13.6 times 1000. So this gives us the volume of the block of mercury that was displaced. When we punch our calculator, let me punch my calculator. This is 2 divided by 10, 13.6, 1000. This gives me 1.47 times 10 raised to power minus 5 cubic meters. So this is the volume of mercury displaced. Now the volume of mercury displaced is actually equal to the volume of ion in mass. Ion is going to displace a volume of liquid equal to the volume in mass. The volume of ion that is in mass is equal to the volume of liquid that is displaced, which is mercury in this instance right now. So let's just convert this to cubic centimeter. For us to convert to cubic centimeter, we have to multiply by 10 raised to power 6. 10 raised to power 6. To convert to cubic meters, we have to multiply by 10 raised to power 6. That is 1 million. So we have 1.47 times 10 raised to power minus 5 times 10 raised to power 6. So this gives us at the end of the day 10 raised to power minus 5, 10 raised to power 6. Minus 5 minus 6 is 10. Is 1, sorry. That is 1. So you put your 10, the powers minus 5 plus 6 gives us 1. So this is 10 times 147. That gives us 14.7 cubic meters. Just like when we saw before, that this was what we got for the volume of mercury that was displaced, which is also the volume of the solid that was the mass. This is the volume in cubic centimeter. This was what we got before. So there's no point solving question 2 anymore. Part 2 is still the same approach I used before that I'm still going to use. This in the second part of the question, they said what is the density of the block, assuming the volume of the block in 1 is half the volume of the iron block. So if this is half of the volume, then when you double the volume, this will give you the entire volume. You just need to multiply this by 2. 2 times this, that will give you 29.4 cubic centimeter. 29.4 cubic centimeter, which is the same thing as, if you want to convert this to cubic meters, you multiply by 10 raised to power minus 6, or you divide by 10 raised to power minus 6, anyone, and that will give you an answer in cubic meters. So it's as straightforward as that. So we will take a look at another question before, and I'll decide whether to call it a day or whether to solve one more. So this is our question 2. In our question 2, we are told that a balloon of volume 100 cubic centimeter containing hydrogen of density 0.09 kilogram per cubic meter floats in air of density 1.29 kilogram per cubic meter. If the mass of the envelope of the balloon, this is the envelope of the balloon, is 50 kilogram, what is the tension in the tethering cable? This is a tethering cable here. This is a tethering cable. So this is the tethering cable. So the tension acts downward. Let's assume it's turned out to the floor, to the ground. This is the ground. So if this cable is cut, the balloon will just disappear as an escape completely. Not just to control it, but this cable is holding it to the ground. Okay. This is tethering cable. As the balloon is going up, the cable will be unfurled. So now we have the weight of this cable. We have forces, the tension in the cable. We have the weight of the balloon. We have the weight of hydrogen in the balloon, all acting downward. So we have how many forces? We have the weight of the balloon. We have the weight of hydrogen. We have the tension in the tethering cable. These forces are all acting downward. But why does this balloon float? Because the upthrust is greater. Because of the upthrust, you can see that the density of air is greater than the density of hydrogen in the balloon. So overall, the average density of this balloon is smaller than the density of air. That is why it can actually float. That is how it can actually do what? It can actually float. So now, the upthrust from principle of flotation says that the upthrust must be equal to the weight of the object, the floating object. In this case, the floating balloon. The upthrust must be equal to the weight. So the upthrust in this case must be equal to the weight of the balloon plus the weight of hydrogen inside the balloon plus the tension plus the tension. So what's the volume of the balloon? The volume is 100 cubic centimeter. The volume is what? 100 cubic centimeter. So the volume of air displaced, the volume of air displaced is equals to 100 cubic centimeter. The balloon is floating in air. So we can actually calculate. This is the volume of air that is displaced. So the weight of air displaced can be calculated. Let's calculate the mass of air first that is displaced. Mass of displaced air. Mass of displaced air is going to be equals to, from density is equals to mass over volume. From density equals to mass over volume. Mass is equals to density times volume. So the density of air is what? Is giving us 1.29. 1.29 kilogram per cubic meters. The volume is 100 cubic centimeter. We have to change that cubic centimeters to cubic meters. Hello, sorry, I just discovered a mistake from the question. There's a typographical error. This is actually 100 cubic meters, not centimeter. That is 100 cubic meters. So this is, the units are consistent now. This is 100 cubic meters. We are not changing anything. So the mass of displaced air is 129 kilogram. That is the mass of displaced air. So the weight of displaced air equals to, weight is equals to mass times G. G is 9.8, so that will be 129 times 9.8. So my calculator, times 9.8, I have 1264.2 Newton. So this is the weight of displaced air. Now, from a principle of flotation states that when a body is a mass in a fluid, the principle of flotation states that a floating body displaces its own weight of the fluid, or a body will float when the upthrust is equal to its weight, when the upthrust acting on it is equal to the weight. So, or a body displaces its own weight of the fluid in which it floats. So this is the weight of displaced air. The balloon is going to displace this weight. The balloon is going to displace this weight. And the balloon now consists of, we have the weight of the balloon, we have the weight of hydrogen inside it, and we have the tension that is dragging it down. Those three forces. The weight is acting downward, the weight of the balloon is acting downward, the weight of hydrogen is also acting downward, which is inside the balloon. Inside this balloon. This is the envelope. We have the material of the balloon, the base of the balloon, the weight of that material. Then the weight of the hydrogen inside the balloon. Then this tension in this cable that is also pulling it down, all acting downward. So they have to be countered by opposed by the upthrust. The upthrust must be equal to those three weights. And the upthrust is given by the weight of displaced fluid, which in this case is air. We've calculated the weight of displaced fluid as 1264.2 Newton. Okay, so we have the weight of displaced fluid. So the weight of displaced fluid is equal to the up thrust. Up thrust is 1264.2 Newton from the principle of flotation. So now we need to calculate the weight of the balloon. Okay, the weight of the balloon. They said the what do you call it? The mass of the balloon is 50 kg. Let me rub off this envelope to have space for my calculation. So the mass of the balloon is 50 kilogram. So weight of balloon is equals to mass of balloon times g. So we have 50 kg times 9.8 meters per second. So that would give us, I think my marker is getting faded. I'm going to change it right now. I'm going to change it right now. 50 times 9.8. That is 490 Newton. That is 490 Newton. So that is 490 Newton. So I've just changed my marker just now. So the weight of the balloon has been calculated to be 490 Newton. Next, we need the weight of hydrogen. Hydrogen was the density of hydrogen was 0.909 kilogram per cubic meters. That was the density of hydrogen. So since the volume of the balloon is 100, so the volume of hydrogen contained in that balloon is also going to be 100. So the mass of hydrogen, mH, is going to be equals to density of hydrogen times volume of hydrogen. Density of hydrogen is what? 0.09 kilogram per cubic meters. What's the volume? The volume is the volume of the balloon. The hydrogen actually fills the balloon, so it will take up the volume of the balloon. So that is 100 cubic meters. So at the end of the day, 100 times this will give us 9 kilogram. So the weight of hydrogen, weight is mass of hydrogen, mH times g. So we have 9 kilogram times 10 meters, sorry, 9.8 meters per second square. So let me punch my calculator. This is 9 times 9.8. We have, this gives us 88.2 Newton. So right now we have the up thrust, which is the weight of displaced air, as 1264.2 Newton. We have the weight of the balloon as 490 Newton. We have the weight of hydrogen as 88.2 Newton. So we can put that into this equation and solve for tension. The up thrust is equals to weight of balloon plus weight of hydrogen plus the tension in the tethering cable. So let me just rub off the pad of the board so as to have some space. So the up thrust is 1264.2 Newton, equals to the weight of the balloon is 490 Newton, plus the weight of hydrogen is 88.2 Newton, plus the tension in the tension cable, which we don't know. We can go ahead and solve that. So let's add this plus this. 490 plus 88.2. That gives us we have 1264.2 Newton, equals to this plus this gives us 578.2 plus tension. So solving for tension, this is 1264.2 Newton minus, this is Newton as well, minus 578.2 Newton equals to tension. So let me subtract that. 1264.2 minus 578.2. So we have 686. The tension is equals to 686 Newton. So the tension is equals to 686 Newton. The tension in the tethering cable is what? 686 Newton. 686 Newton. So the tension in that tethering cable is actually what? 686 Newton. So in this question, it was just logical reasoning. We have the up thrust acting upward. We have the weight of the balloon acting downward. We have the weight of hydrogen inside the balloon acting downward. We have the tethering cable dragging the balloon downward, not allowing the balloon to escape. If that cable cuts, that balloon will just disappear, with also is occupying it. So at the end of the day, we just use logic and we are able to calculate the question. So we are done with this question. Thank you for your patience. Just make sure you gradually take time and work on follow up on the solution process. If you have any question, drop it in the comment section. Okay, and like I said, if you're not subscribed to this channel, go ahead and hit the subscribe button. Go ahead and do what? Hit the subscribe button, and also hit the like button as well, and drop your comments if you've actually enjoyed the class, or there are ways you feel you can actually improve on our delivery. Just drop them in the comment section. And if you need a one-on-one online lesson or offline, just connect with me via my WhatsApp number +2348038295185. Thank you and bye. We'll meet in the next lesson.